All right, this is going to finish off chapter 8.1. So we have about 6 more questions having to do with these two similar figures. Don't know how to describe them. They kind of look like triangles with like a corner, with the bottom left corner cut out. So we're going to answer questions about the scale factor, finding some missing measurements, looking at the perimeters, looking at how the perimeters, what the ratio of the perimeters are and the ratio of the areas. Okay. All right, so let's first look at the scale factors. Okay, let's do the scale factor from the ABCDE figure to the KLMNP figure. Okay, so that's going from small to large. So to get the scale factor going from the small figure to the large figure, we have to find a pair of corresponding measurements, right? And right now I'm looking at the kind of top left measurement here. So on the small figure, it's 2, and on the big figure, it's 3, okay? All right, so I'll take the bigger measurement and divide it by the smaller measurement to get 3/2, or 1.5. So in other words, the big figure is 1.5 times the size of the smaller one. This is 1.5. You can write scale factors as fractions or decimals, it doesn't matter. Okay. All right, so 1.5. Now question 4 is asking for the scale factor from KLMNP to ABCDE. So now we're going from the big to the small. From the big figure to the small figure. Okay. So it's the same approach, right? We're just going to take, we have to find a pair of measurements, right, and then form a ratio. Okay. So now let's just go ahead and use the bottom measurements, right, which is the same as the side measurements 2 and 3, 2 and 3, okay, except we have to be very careful with how we form the ratio, right? We're going to take the small measurement divided by the big measurement. Right, which makes sense because we're now trying to reduce the size, so the scale factor should be less than 1. Here we were enlarging, so the scale factor would be bigger than 1. Going this way, we're reducing the size, we're shrinking, so the scale factor is going to be less than 1. Okay, it's 2/3, which is about 0.67. Okay. So the figure on the left is 2/3 the size of the figure on the right. Next, let's find the values of x, y, and z. Okay, so x is side length of the big figure. And so I know that in the small figure, the corresponding measurement is 1. Okay, if I'm scaling up, I need to multiply by 1.5. So I'm going to do 1 times 1.5 to get this measurement here. Okay. So x is going to be 1 times a scale factor 1.5, so it's 1.5. Let's write it here, 1.5, 1.5. Okay, y, again, y is a measurement from the big figure. Okay, so what we'll do is we'll find the corresponding measurement in the small figure, scale up by the factor 1.5 to get y, right? So the diagonal length here is 3√2. We're scaling up, we're enlarging by 1.5. So multiply this by 1.5 and that'll give us y. So y equals 3√2, which is the measurement from the small figure, times 1.5, the scale factor when we're scaling up. Okay, so here you just multiply the non-root parts. 3 times 1.5, I believe, is 4.5. So this is 4.5 times √2. Yeah, okay. I can leave it like that. Okay, so 4.5 times √2. Right. The last variable to solve for is z. Z is an angle, okay? And so we can see the corresponding angle in the big figure is 45 degrees, okay? Now remember, similar figures have the same shape, which really boils down to having the same angle measurements, right? So all the angle measurements around each of these figures is going to be the same. So if this angle is 45, then this angle is going to be 45 degrees as well. So Z equals 45 degrees. Okay. All right. So now let's go ahead and calculate the perimeter of both polygons. Okay, so we're going to add up all the sides of this polygon. Okay, so for the small one, it's going to be 2 plus 1 plus 1 plus 2 plus 3 root 2. 2 plus 1 plus 1 plus 2 plus 3 root 2. Okay, I'll use the calculator to approximate this. 2 plus 1 plus 1 plus 2 plus 3, 2. Okay, it's about 10.24. Okay, and then if we look at the perimeter of the big polygon, that's 3 plus 1.5 plus 1.5 plus 3 plus 4.5 root 2. So 3 plus 1.5 plus 1.5 plus 3 plus 4.5 times root 2. And that's about 15.36. All right, so we have the two perimeters. Now let's find the ratio of the perimeters, A, B, C, D, E to K, L, M, N, P. Okay, so I think we'll take the perimeter of the big figure divided by the perimeter of the small one. Right? We're going in this direction. So 15.36 divided by 10.24. Let's see what this is. Oops, what did I do wrong? 15.36 divided by 10.24 is 1.5. Okay. Now that shouldn't be too surprising because we already knew that the scale factor of an individual side length was 1.5, going from small to large, and the perimeter is just the sum of all the sides. Okay, so if each individual side is scaled up by 1.5, then the entire perimeter, we would assume, would be scaled by the same factor, 1.5. All right, let's find the ratio of the areas. Okay. All right. So let's see. How do we find the area of the small triangle? Well, let's imagine that we filled it in there. That we made a big triangle there. Okay. The side length would be 3, right? 2 plus 1. The bottom length would be 3 as well, 2 plus 1. Okay. And so the area is for a triangle is 1/2 length times width. Okay. So that's 9 halves. Okay. But we then would need to subtract away that little corner piece, which is a square, a 1 by 1 square. So minus 1 times 1. So this is 9 halves minus 1. That's 4.5. So this is 3.5. All right. Let's find the area of the big figure. Okay, so again, let's go ahead and fill in that corner so that it's a complete triangle. Okay, so this side length is 4.5, right? It's 3 plus another 1.5. The bottom length is also 4.5. So 1/2 length times width, 4.5 times 4.5. And then we'll subtract away that little corner there. It's a square, 1.5 by 1.5 square. All right, let's use the calculator to figure this out. So 1.5 times 4.5 times 4.5. So it's 10.125, and then 1.5 times 1.5 is 2.25. All right, so the difference there is 7.875. All right, so we've calculated each area. It's kind of a process, okay? And now we want to look at the ratio of the areas, right? So to form a ratio, you just create a fraction. We'll take the big area divided by the small area. So the ratio is going to be 7.875 divided by 3.5, which equals 2.25. So what we found is that the area of this big figure is 2.25 times the area of the small figure. Now here's something worth noting, is that the ratio of the areas is actually it's the original scale factor to the second power, right? So if you take the original scale factor and square it, right? So that's 1.5 squared, you would get 2.25. So had we known that fact ahead of time, right, then we could have skipped all this and just said, all right, well, since I know the original scale factor, I'll square it, and that'll tell me how the areas are related to each other. Okay, but we went through the math to show you that it actually works out. Okay. All right. So in general, the sides will have a certain scale factor. The perimeters, which is just the sum of the sides, is going to have the same scale factor. Okay, but the area is a two-dimensional type of measurement. Okay, and so that is why we raise the scale factor to the second power, because area is now two-dimensional, whereas side lengths and perimeters, those are just one-dimensional measurements.